Hey everyone, welcome back to my class. In today's section, we are going to study about the importance of species diversity. In species diversity, we are going to talk about two topics, that is provide stability, and the second one is going to be ecosystem health. Let's see one by one. When we talk about provide stability, this concept was given by Tilman. So we also call it as Tilman experiment or plot experiment. Okay, now what did he do? What did this experiment says? It says that he related number of species with the productivity. He said that he wanted to show that how number of species are related to the productivity. Now, when we talk about the second, that is ecosystem health, it was given by Paul Ehrlich, and we are going to study the Rivet Popper hypothesis under this concept. Right? Now, what did he do? He related number of species with the stability. So, Tillman related number of species with the productivity, and Paul Ehrlich related number of species with the stability. In today's class, we are going to see only the Tillman's experiment, right? Now, let's move ahead. When we talk about the stability, I know that more the diversity, more is going to be the stability. Why? Because more species are there. So, obviously, my ecosystem is going to be balanced. So, can I say that more diversity is going to give me more stability in the ecosystem? Obviously. But by this, I am confused. What is the meaning of stability? What do I want to say? When I say stability, what I am properly referring to it? Let's see one by one. More stability means the less variation or less fluctuation will be there in productivity. What is productivity, class? Productivity is nothing but what plant. Suppose a simple example, if I want to take it, I'll take a plant, right? Plant will be there. Plant is going to do photosynthesis. Now, after photosynthesis, the food which is produced by the plant, we call it as productivity. Productivity. Now, this productivity we calculate as a biomass, which we calculate in kg. Right? So, this is about productivity. So, if we have more number of species, simple example, if I want to take it, let this be one area and let this be other area. So, if I have 10 species over here and if I have 100 species over here, so due to any natural calamities or man-made activity, if some or the other species die, let's imagine that the 5 species die, so only 5 will be there. And here, even if the 5 species are dead, what will happen? 95 species are there. So can I say the productivity will be more for B1? Why? And stable, not more actually, it will be stable. Even if 5 are dead, we have still 95 species. So the productivity will not fluctuate. Less variation you will see when we talk about the productivity. Resistant to man-made activity or natural disturbance. What is the meaning of resistant? Resistance means I can say it is, it can oppose or non-effective. Non-effective. A simple example, if I want to give you, I can give you an example of antibiotics. Antibiotics we will be using against bacteria, right? But also we have heard that some of the bacteria become resistant to antibiotic. That means antibiotics are non-effective on them, or they are going to oppose antibiotics, right? So resistance means oppose to man-made activity, the activities which we are doing, lots of chemical spreading or cutting trees, all these things we are doing. Natural disturbance, for example, your flood, tsunami, cyclone, all these things. So all the biodiversity which is present, all the species present in the biodiversity, they should be resistant to man-made as well as the natural disturbance. Then only my ecosystem will be stable. Then the next one is resilient to rejuvenate or reestablish. What is the meaning of resilient? Now you must have heard many a times we get this news that in Japan earthquake happened, right? So due to earthquake, what happened? Obviously lots of damage happened in the Japan. But can we say that okay, there is no Japan here after? No, obviously not, right? What happened? The damage is done and then again re-established. There will be again re-establishment of that particular area, right? Again there will be the formation of all the biodiversity which is present over there, which was present over there, right? So resilient is nothing but when something which is disturbed, when something which is destroyed, again the ecosystem is going to be maintained over there, that we call it as resilient or rejuvenate. Okay, again I'm repeating myself, resilient is nothing but re-establish. Re means again, again establishment will occur, that means something which is destroyed completely, but again my ecosystem is forming over there, that kind of biodiversity we call it as resilient, right? Now next one is resistant to alien or exotic species. All are same class. If I say alien or if I say exotic, if I say foreign, all are same. So resistant to alien or exotic species means just imagine that there is a pond, okay, and there are lots of species present over here. Now these species are happily enjoying over there, they do not fight for the nutrition and all this stuff. One day an alien species, let me say this alien species is going to be Gia, okay. Gia enter into this pond. Gia enter into this pond. So what happens? Suppose Gia is very much dominating. What Gia is going to do? Gia is going to fight for nutrition with all the other organism, and probably there is a chance that these alien species will destroy the native species. Okay. So if that happen, my biodiversity will not have stability. So to maintain stability, what I have to do? To maintain stability, I should make sure that my biodiversity should oppose the alien species. It should resistant to the alien species, right? Now last one is species diversity is more. This is the most important one, class, because if the species diversity is more, automatically no matter what is happening, whether it is a man-made stuff or natural calamities or some or the other thing happen, obviously I have lot many number of species, so it can always resilient, it can always rejuvenate. But if I have less number of species, then it won't be able to resilient or rejuvenate again, right? I hope this must be clear to you. Now the experiment which we are going to deal with in this topic, regarding this topic, it's going to be the Tilman experiment. We also call it as plot experiment. So Tilman experiment with the outdoor plot. Now imagine this, we can consider it like a whole forest. Let's consider it like a whole forest, and Tilman divided the whole forest into plots, like I am doing, right? So when I divide it into plots, you can see very carefully over here that if I talk about plot this, it is, let me change the color. Okay, so if I talk about plot this, then obviously you can see lots of greenery is present over here. If I talk about this plot, then there is no greenery over here. If I talk about this plot, greenery is there. If I talk about this plot, half is greenery and half non-greenery area is present, right? So Tillman, what he did, he divided a particular area into plot to figure out what happened and how things happen, right? So Tillman's experiment with outdoors plot showed that plots with more species showed less variation in the biomass. He also showed that increased diversity contributed to higher productivity. These lines you will understand with this experiment, okay? So let's take an example of plot number 1 and plot number 2. When we see plot number 1, just forget this alien species. Let's talk about the normal species, okay? So all these green color trees are different species, okay? So when we talk about plot number 3, how many species are present here? 3 species are present. When we talk about plot number 2, how many species are present? 13 species are there. So which plot has more species? Plot number 1 or plot number 2? Obviously plot number 2 is having more species. Just imagine one day, due to some natural calamities or man-made activities, let's just imagine that my one species got extinct. One species got extinct. Previously, per species was giving 10 kg of productivity. Let's imagine that, okay? 10 kg of productivity was given by each species. So initially we used to get 30 kg of biomass, 30 kg of biomass, but one got extinct, so now I have only 20 kg of biomass, right? Now see here, already 20 kg is very less because we have less number of species. Here 130 species, each species will produce 10 kg, that means 130 kg of biomass is produced. Now let me kill 2 species, so I am going to get 110 kg of biomass. Now class, tell me which one is more, 20 kg or 110 kg? Obviously it is going to be 110 kg, right? So productivity is maintained where the species are more, where the biodiversity is more, then the productivity is going to be maintained, right? Now let's talk about the alien species. When I talk about the alien species, just imagine plot number 1, one alien species entered. Now this alien species will fight with the native species for the nutrition, right? And now this alien species is dominated, so there could be a possibility that it is going to destroy my 1 or 2 species, right? So already if it already we have only 3 species. If it is going to destroy 1 or 2 species, how many species will be there? Only 1 species. That means productivity is going to be 10 kg, right? But here, even if 2 alien species are there, if it is going to destroy 1, 2, maybe let's see 3, but still we have lot many species to give me good amount of productivity, right? So there will be less variation in the productivity when we talk about the plot number 2 as compared to plot number 1, right? Now let's see over here. Plot number 1. Plot number 1 will have less biodiversity because less number of species are present. What about plot number 2? More biodiversity is present. Plot number 1 is less stable. If something happened to one of the other species, then the stability will be gone because already less number of species are present. But plot number 2 has more stability. Why? Because even if something happened to this species, we have lot many more species to carry forward or to balance your ecosystem. Not carry forward, but to balance your ecosystem. Then we have less biomass. Biomass is what? Weight in kg. So less productivity is there because we have less species. What about plot number 2? We have more biomass as the more species are present over there. These are less resistant to man-made and natural calamities. Already less species are there, na? That's why. These are more resistance, more specificity, more diversity is present. So these are more resistant. Less resilient. Once damaged, it won't be able to reestablish itself. Now let's just imagine, even if it is able to reestablish itself, obviously it will take lots of time, and meanwhile other species will be destroyed. So it is going to be always less, right? Now more resilient will be there for the plot number 2. Less resistant to the alien species. We saw over here less resistant to the alien species, but when we talk about the plot number 2, more resistance to the alien species. More variability in productivity. Why? Because if 1 is gone, 2 is gone, so there will be more fluctuation in productivity when it comes to the plot number 1 than as compared to the plot number 2, right? Now let's take another example, plot A, and this one is going to be plot B. Plot A has 100 species, plot B has 500 species. Let's see the annual productivity, that in 1 year how much of biomass is produced in kg. 2020 it produced 50 kg, 21 100 kg, 22 140 kg. See the difference. One is 1 year 50, another year 40, right? Let's come to the second plot, that is 2020 100, 2021 110, 2022 120. If we'll see, only 10 differences there. So which one is showing the more constant productivity? It is plot number B. But if you see plot number A, big variation is present, right? A lot of variation is present in plot number A. So which shows more variability in productivity? Obviously your plot number A as compared to plot number B. What is the reason behind it? The reason is that we have lot many species, so biodiversity will be more. So more stability will be there in the productivity, right? So that's all we have in today's class for Tilman experiment. Next Rivet Popper experiment we are going to see in the another class. Thank you.